Anything I have to address right away? The last question here was the one I just read a few minutes ago before the break. Okay. Replicate the sample for 3 times or inject the sample 3 times. Okay, the replication. Okay, if we read, let's look on the PowerPoint, and it's a replicate 3 times. Let's do that. Okay. Oops. Here. No. Got it wrong. Let me find exactly. Where's that? Okay, here. Let me make this big. Okay. It's still okay. I know a lot of people still on the break. That's fine. Okay, you see this. If you look on the screen, we have sample here 6, 1, 2, 3, B, C, D. Those are 3 separate samples, 3 separate extractions. So when you do the extraction, you have this sample spike. The sample itself, sample name is called the 6123. That's sample name. You spike the first sample, which is A. That's a control. You don't spike anything. That's one sample in one bottle, one extraction. Then the second one called a B. That's a spike. That's a C spike, and the D another spike. So you have totally 4 samples: control, spike 1, spike 2, spike 3. So you do extraction. And in this case, you will see, of course, recovery is high, it's 90%. And you will see control is not here. And this is a different lab. This is a New York lab. Okay, in Cornell University, they did this, which is different from my lab. I will show you my lab. The format is different because they do not show the control here, and the numbers here does not give a meaningful information, which is fine as long as in your lab it's restricted this way. That's fine. And also the significant figures are different, and that's good enough for our purpose. And I will show you my lab, what's the situation. So yes, the sample is triplicate samples, 3 different extractions. Okay, let's move on to the question okay, double injection. Okay, this is something continuing that question. So when we have 4 samples now, we have control, we have 3 spikes. Okay, now each of the sample, you will need to inject twice. That's called a double injection or dual injection. Okay, so in this case, a sample, we have definition there. Well, why we call double injection, okay? This is IR4 term. This is not necessarily itself English, okay? It's IR4 term, there's a definition there. The definition there is you have samples, you analyze it, okay, in the order injection 1, injection 2, injection 1, injection 2. So one sample, let's say this is sample control, inject twice, 1, 2. Treat the sample, 1, 2. Treat the sample, 1, 2, like that. Okay, keep going. Each sample inject twice, okay, consecutively. That's called double injection in IR4 system. Well, there are a lot of reasons there. EPA does not necessarily require you to do double injection, but EPA wants you to make sure your numbers are correct. Okay, now it's getting a lot of other things, which I will mention later, how you handle the data, because your data, you got a lot of data now, which will be different. And also, in different countries, in different different agencies have different requirements. For example, if you need to get your data accepted in Canada, they will require multiple injections. That means more than one. It does not have to be, quote, double injection, unquote, like AR4, which is consecutive injection, because the injections together, side by side. In Europe, most likely they will require that. So it depends on where you go. So to be the safe side, EPA does not require that, but requires more accurate number. So in order to be safe side, do everything double injection. Or you inject the first time, or at the end you inject one more time. That's fine. But that's not IL-4 definition double injection. So double injection have good one because sometimes you may have some issue by instrument. Sometimes it's the sample, sometimes it's instrument. In my career in the past 20 years, the double injection, I had probably 2 or 3 times problem. So not so many. So basically versus what you do 1,000 times or maybe like 5,000 times injections, you have like 2 or 3 times something wrong with the instrument. That means one injection is good, the other one is not good. So it is important, you need to do. It's necessary when you do the mitigation, this study. It's necessary when you do the EPA work. It is also necessary you submit the JMPR petition for pesticides. So yes, let's do. Sometimes we call it multiple. The multiple means you do more than one, okay, but you do not have to do double, which is side by side. So this is continuing the question answer what we had just a few minutes ago. It's called multiple. So okay. So now here opens the door to another discussion or discussions because you have multiple data now. Okay. Now here says you do double. Okay, sometimes not required, but we do that. Okay, but some of them. Then you have multiple results. And those double or multiple, for example, you inject first one, number 1, you inject the 2, number 2, and you may have more than that. You have 3, 4, 5. So how you handle this? Why do you say, okay, in your lifetime you got 3, 4 times wrong? Why it's wrong? How much different is no good? Okay, so between 1 and 2, how much is there? Okay, so what we say, if it is below LLMV, you really don't care. Is that right? So basically, you don't report anything. So double injection doesn't matter, especially when you go down very low level, and the error by percentage is huge. Okay, if number is 0.001 versus another number 0.002, and this will be 100% error, which analytically this is not acceptable at all. But for our work, we know this is way smaller than the LLMV we need, which is 0.01. We don't care. So in this case, we will accept the data. If it is above LLMV, for example, if we remove the 0 there, then we do care. This 100% error is not acceptable. No, that's not good. So we need to set up the requirement or criteria there, which in different labs, they have different one. Some people say that 10%, some people say that plus or minus 15%. It depends on first of all, depends on this level, the residue level. If the residue level is very low, this number is quite going high. If the residue level is 1 ppm, for example, if this is 1 ppm, then that's huge number, 1 and a 2. Then for sure it's not acceptable. But if it is 0.00, I mean, it's 0.01, 0.015, you will accept that because it's very low. And when you do the calculation, you will do a OECD calculation, the number is the same. So you will accept that. So I would say 15% is quite a good number for us to handle multiple injections. So the next is we're going to talk about, we do the analysis, how we do that, and then we will talk about the criteria, how we accept the data. Okay, so this is called a set. Okay, we know that a set of sample, what is a set? It must have at least one control, at least one QC spike, then the treated samples. If it's method validation or storage stability, it must be in triplicates. And it's always good idea to put a solvent blank there. Okay, and it's always there. You need to have calibration standard before and after. So this is the set we have, and this is the requirement for our work. Okay, EPA does not have very restricted regulations or requirement on this, but this is recommended. And for most countries, EU, Canada, Australia, Japan, this is all accepted. So that's okay, you will use that. Let's read that. So we will have a full set of calibration at the very beginning, a complete set, it's calibration. So normally it's 6 points, minimum 5, normally 6. Okay. Then the option, this solvent blank is the option. You do not have to have there, but for scientific purposes, because that tells how clean your instrument is before you do the analysis. So it's good. So yes, we'd always put 1 there, at least 1. Then we have the control. This is must be there, at least 1 control. Sometimes you do multiple. Okay. The control is there. Then you do the spike, which sometimes we call that QC. Sometimes it's the method validation. So at least 1. If it is method validation, should be in triplicate. It must be 3 samples here. So that will, if it is method validation, that will be 3 samples here. Okay. Then you will have all treated sample. We say that short TS, treated sample. And we say this short, we call that a QC. Okay, then it's always good to have this blank here, because if the field sample, you don't know how the residues will be. So if the residue is very high, you will have a carryover here. And when you have another set of calibration, it may not be very good. So basically, we do another set of calibration. Okay, so these are the general sequence or work list. That's the adjuvant. We call that work list. It's adjuvant, I believe, adjuvant. If you are using Waters instrument, it's typically called that sequence. And most likely, most other instrument, they call that sequence. Okay, so that's called a set. So that's called a set. Although in the lab, you may call that a batch or a sequence or set or whatever you call it, doesn't really matter. Okay, so we will see for calibration, so it should be minimum 5. It says minimum 3, but it should be 5 or 6. Sometimes I do 6 or 7. So the points for calibration. And you have the line there. So you have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So that's typical, 6. Okay, but normally it's like that. Okay, so that's another question is different country, different place may have different requirements. Some of them requires different set of calibration standards. Some of them requires alternating. You do two series calibrations. You alternate them. So that will tell if something is wrong, you can check each other. So it depends on that. When that sense comes up, we will go through this again. But for example, in Canada, it's different from in the U.S. So the requirement is different. Okay. Okay. So okay. For the QC here, as I mentioned, in different countries, different area, they have different requirement. Some places you have to at least one LLMV level, which is 0.01 as the QC, at least one. Okay, so it depends. So I would say for the safe part, you do at least this level. Okay, so that's the requirement because your data will be accepted in that country or in EU or JMPR. So that is the one. Okay. The next slide is the real work list we work on. Oh, I do have a question here. In work list for injection, I don't see untreated sample. Let's go back. This, okay. Let me erase that because it's getting too complicated. Okay, erase this, erase that. So the untreated sample in our turn, EPA turn, is called control. So the control in this sequence or work list, which is this one, which is you do not have any treated, you do not spike any standards, or this is not a field. This is a field sample called a TS, treated sample. And for the concurrent spike, we always in the lab use a term, short term, we call that a QC sample because you're gonna check the recovery. Okay, so that's some kind of thing we talk to ourselves, but the official term in the EPA GOP is concurrent spike sample. Okay, so this one in the lab we always say that control, just say that control, also that CS control sample. They say that short control. We say that in our lab control. So that is the untreated sample. Okay, that should answer your question. And that's Dr. Nian. Okay, this is, of course, it's a little bit too small to see this slide, but that gives you overall for the sequence. You do not have to run one set in one sequence or one work list. You can have multiple together. So that gives you the idea what's going on, that you can run multiple. You can run 3, 4, 5 if you want, because the machine can keep running. And also you treat them the same way as we just talked about. Let's read it, okay? Here, from here, let's say from here to here, that's the calibration. And this is solvent blank. And this is treated sample. No, this is untreated, which we call that control. Control. Okay. Then we have call that QC. We have this is QC. We put a QC here, QC, and we have QC down here, QC. Then starting here, going here is treated sample. We call that TS. Then it's calibration again, down here. And in between there's another blank. So what we can tell, this is an example, what we can tell from this going to the top, going down here, that's called one set. Is that right? We meet all the requirements there. Let's read what the requirement are calibration. Let me erase this. That's a little bit too complicated. Let's remove that. Okay. So, okay. First, do we have set of control? I mean, the calibration. So calibration at the very beginning is a whole set of calibration. At the very end is a whole set of calibration. So this one we will see. This is calibration here, whole set, everything. And this is a whole set of calibration here. So that is good. We don't have problem. Then what we have solvent blank here and solvent blank there. So let's read. Do we have solvent blank there and solvent blank here? We have one solvent blank here, and we have one solvent blank here. Okay. Then we have one control minimum and one concurrent minimum, which is QC spike. So we have one control here. This is the control. We have one. We have one QC here. We have another QC here. Then the rest of them is treated samples. Okay, then we go here, treated samples, field samples, treated samples. So you can put as many as you want there as long as you meet the requirement. So this is called one set, which meets the requirement. So we also see double injections. You will see this is double injection. This is double injection. And this J3 is also double injection. J2 double injection. J1 double injection. So it is double injection. Okay. So what we can say, let me erase all these. So we don't need any of that. So we do know which is one set now, but we put more than that. Okay, let's erase whatever we see there. So we talk about sets. We know everything's good. So this is one set from here down to here. This is called set 1. And we do exactly the same thing. We count from here, go down to the end. That's called set 2. So basically, this part is in between. You can keep going, this work list, keep going. You can put 3, 4, 5 together. So this is an example to show you can have multiple sets in one sequence or in one work list. Okay, so the question here, next one is when standard calibration before and after differ significantly. Dr. Suri asked the question there. If you see some curves difference, what do you need to do? Well, this is happening all the time. This is, oops. Let me erase these things. Okay, let's just do the real work. Well, let's explain a little bit this time now. Yes, we do see this thing. For example, this is the calibration. This is the calibration. This is the concentration down here, and this is the peak area. Okay. Then the set 1, this is set 1. Let's say we put dot there, set 1. That's typical, something like that. Not necessarily straight line, but it's good enough. And set 2, we use different color. That could be going down a little bit. I thought I would change the color. Not. Okay. So the set 2, it could be go down here, go down here, go down here, go down here, like that. And it's the same concentration, of course. They are all the same concentrations. And you will see set 2, the line is like that. And set 1, the line is like that. That's happening all the time. Okay? So, yes, there is a requirement. how much difference is supposed to be. Okay. I would say in my lab, we put it there like a plus or minus 15, I believe. So it's equivalent to double injection. Your double injection, if you do that, if it is within 15%, you will accept that. And for the standard, most likely, if it is a spike well or it's a solvent, it should be less than that. Otherwise, that means you have carryover from the treated sample. This happens all the time because your instrument is getting dirtier and dirtier. The response will go low. But this kind of like this kind of a shape is always there. And another good question is it always depends on the last point, because last point is always high. If it moves a little bit, your curve will change significantly. So you need to change this accordingly. So you do need to have this. And well, the best way is you calculate the R value or R squared value for the lines. You can calculate as one line, and the R squared value will change like this. Or you can calculate two lines. You can calculate, then use the intercept. What's the difference there? So if the difference is too high, bigger than 15%, or your recovery will change significantly, then it's different. Okay, of course, if it is within this range, and your recovery should be in a certain range. So which number you should use? You should use the first line or you use the second line. So that's always the question. Okay, what we do in our lab, we use both. We average them. We use every single point. This is 1 point. This is another point. This is 1 point. This is another point. This is 1 point, another point. So basically, if we have 6 calibration curves, we use 12 points for calibration. So 2 of them the same. If you do the double injection, then that will be 24 points for one. And you treat each one different number, different points, the R squared value will change significantly, will go down significantly. So that's a good indication the calibration is good before and after. So we will go through the criteria in a few minutes. This is our New York data again. This is New York lab. Okay, and you will see they have untreated here. That's double injection. They have treated here, and they have QC here. So this is meeting the requirement we just talked about, the double injection. And you will see this is double injection because it is right after each other. It's not just like you analyze first time, after several injections, analyze it again. That's not called, quote, double injection, unquote, because it's different. It's not our IR4 requirement. IR4 requirement is double injection is inject right away. The next sample, injection right away. So they are doing the good thing here. And you will see, we see the recovery down here, and we see all the numbers. Of course, treated sample in this case is very low, lower than the LLMV. So you don't care about anything. So even the numbers is different. So you don't care about that because it's below the LLMV. Okay, so that's this part. And of course, we have a lot of sample information there and all the data down here. Okay, so that's okay. Let's look the Michigan State lab. What kind of format we have? We have similar one, but I personally believe our form is better than theirs. But it depends on your opinion, of course. So this is our form. We have a calibration curve there, which make a little bit straightforward. You can see it right away. Okay, you got this is a 6 point. This is 1, 2, 3, 4, 5 points calibration. You can see the curve here, and it do have R squared value 9968, which is quite good. And yes, you do see the difference before and after. You see that this is a before. It's going this one. let me just make the color a little bit easier. The red one, this is before. And you will see before the number, the biggest number is 2,000 area count. And the after one is, in this case, is 1,900, which is this one. Yes, you do see difference. Yeah, it happens all the time. It's not just like you will get that good number matching very well. So in this case, this is much small. The error is here. Yes, it is some kind of a difference there. It's not that big, but it's acceptable. So now it is getting, the question is, when this is getting bigger and bigger and bigger, then that will be a problem. Okay, we will talk about that, and we will see, this is the page number. You will see that this is the page number. And you will see the calibration. This is all one full calibration from 115, 116, 17, 18, 19. So it's sequential order. Then this is run anything in between, or the samples in between, then another set, another full calibration. What are these in between? Here are all here. These are the samples in between. So you will see there will be a blank 120. That's a blank here 120. We don't need to put a blank there. We know blank is always, should be always nothing. So the page number should be 120. Then that starting 121, that's the double injection for control on treated sample. Then there's a QC sample, 23, 24. Then the rest of them is treated sample by double injection, 27, 28, 20, 27, 28. Then it's going back 25, 26. I don't know why. Oh yeah, this is because sample order. Okay, and you see this is the spike level is 0.005. It's less than 0.01. And recovery is about 100. Okay, we do have some questions here. Dr. Suri asked a question. No, not Sunil. What R value is good? We will talk about that in a few minutes. The criteria. So the R squared value, we use R squared value. Okay, which in this case, specific case, this is 9968. We have all the information there. We have the slope, intercept, and OQ is there. So that's something. So this is my lab information. I know as some people went through my training, you probably are using my form, another New York form. We do put the control there, but we don't put the blank there. So this is one set. Okay. Let's go on the next. Okay, the sample analysis. So the next we will say what's really going on. If your residue is very high, we go here, we see the residue is here. Okay, it's like a 0.08, 0.05, and you will see the double injection here and see how much differences are there. Of course, it's probably too small for you to read, but I can read the numbers to you, okay? If we round everything up, the first sample, this should be IR4 sample C, first two sample, that's one sample. The sample rounded up is 0.08 ppm. Okay, now the IR4 sample D here, you round it up is 0.06 ppm. So we do know in the IR4 system, C and D should be the same sample, but they put in a different bags, different samples. It's just like a sample is in the field, it's just like a triplicate. But in the lab, we treat them totally separated. It's okay. So in this case, there's a good indication the analysis is good because the difference is very small. So yes, we can accept our analysis based on the QC recovery, based on clean control, and based on the double injection, so good. The R squared value is good. So these are the requirements we put there. Yes, they are good. Okay. Sometimes people say the R squared value should be greater than 99, 0.99. It depends on your SOP. My opinion is, yes, 0.99 is good one. Yeah. And this tricky thing is it always depends on the last point. So if the last point is close, you will get this R squared value 99 easily. If the last point is not good, even the rest of them is really good. Okay, these are really good. And this one, if you have number here, you will get very bad R squared value. That's because when we do the calculation, we know that how we calculate R squared value is that, well, this is the curve in the middle, is the distance to the curve, and square that. Then divided by the number minus 1. That's equivalent to a lot of calculations there, which is like a standard deviation type. So in this case, the difference here is big, the delta, the difference big. Versus here, even the percentage here is big, but real number is small. So in this case, this is the point, is the biggest thing you need to worry about. So if you just talk about R squared value, so the last point is always the biggest one you need to worry to get to the R squared value. Can we handle that? Can we use in a different way? Yes, you can, but it's getting more complicated. For example, if you do calibration, your instrument has a function called weight. This is the science part. There's nothing wrong you use the weight. It's okay. If you weight your standards. In the other words, you treat, if you do know your calibration points are good, okay, you make them very, very accurately. Every single point is very, very accurate. So they should be treated in the same way. Rather than this one, you use the biggest. This is because absolute value is big. Then you can weigh them in the same way. There's a lot of different weight. You can go over, typically it's 1 over x, which is based on the concentration. This is x, this is x. Okay, so based on the concentration, then you will say if you treat all those points are the same, then you will get a better value, especially when you go down to the lower concentration, because the higher concentration doesn't matter too much about that. But the lower concentration will be a bigger one. So in this case, you can calculate, and the recovery will be, if for example, if it is real, this case, if we do the 1 over x, well, we don't have any weight here. Okay, it's linear, but we don't have weight. Normally, we put it there. Then I will get probably around 100% for both of them, very close, or 99, 98. That's because the weight, you treat them the same. But this difference really makes a big change in terms of R squared value without weighing. So you can do that, but if you by hand to calculate, it will be difficult. The software can do that. So I'm not going to talk about this. This is another paper. You can write it down. Okay. The lab records could be any kind. I went to all the labs. Your record should be okay if you can catch all activities. I'm not going to go to the detail how and why. I don't like this kind of the records because it's too much writing. I like something like a form. You have box there. You check the box. You have something you need to write something, just the date or some number. Okay, and this is 10 grams of sample. You write it down something like that, rather than keep writing the wording like that. I don't like that. But that's okay. As long as you follow GOP, you record everything, that's okay. But this is not efficient because you may make a mistake, keep writing, because people make mistakes. Okay, so what's really important? Well, anything you need to talk to the study director. Good thing, talk to study director. Bad thing, talk to the study director. Everything you have to put in the log, in the book, record. So That's documentation part. We don't have time today to do that. If I go to your labs, I will for sure to check all those things. Those who went through my training, you know that how many times I say documentation, 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 and how many times I said, oh, this is SOP. What's your SOP? And GOP. You probably can count that. At least I say these wording at least 100 times a day in your lab if I go to your lab. Okay, so let's see the criteria. So some of them is GOP, some of them is protocol, some of them is the guidance, some of them could be your own preference. So the spike recovery, which is the most important part, and the EPA requirement is 70, 120. And this, so far, I found is just everywhere use this range. I know somewhere is a little bit more restricted, put it 80% to 120. That's okay. So it depends. So I would say 70 through 120, this is overall. Okay, so double injection, a lot of times it's not necessary, but in our work, we really do prefer, especially on treated samples, okay, including untreated control. So we call that weathered sample, means you get from the field. So we need to do multiple injection, sometimes more than two. Okay. Okay, we need to get linearity, so it depends on instrumentation. So I really prefer if you do LC-MS, this is the one. If you use old equipment, like old GC, you put in your SOP 98, I think that's probably okay. So yes, I do prefer something 99. So that answers the question there. Say R squared value should be normally no less than 0.99. Okay. Another question, Dr. Farr said, how often and what compounds you use for internal standard multi-class pesticides residue? Well, we say we have to say a couple of things on the side. We say our works, the residue studies, like this pesticides, the mitigation study, or registration or JMPR submission, which most likely we are talking about at this time, and for those doing tolerance or MRL work, in this case, you don't have like hundreds pesticides to analyze. You have specifically how many, parent, metabolite, or mix, maybe like 2 or 3 or 4. I never saw anything more than 8 in our study. So in this case, it depends on your method. You may or may not need to use internal standard. And if you do use that, make sure your method accepts that, because this is a big change. This is a major change. So the first question is, if your method does not support that, don't use internal standard. Don't make your own internal standard. Forget it. Okay. If you do the multiple residue for not this purpose, for not residue purpose, you probably can purchase something specifically for the certain range that the retention is right in the middle, very close to the chemical structure. You can get that as a group to do that. So that's a different question and different requirement. It's different from what we are talking about today. So in this case, you need to validate your method. If that is okay, that should be fine. But for the residue study for MRL, it should be following the requirement of the method, and always talk to the study director if you can use a different one for the internal standard. So I say that short. Most likely this does not apply. So you do not have that choice. Okay, the next one is the calibration. So in some places you have different calibration. For example, Your SOP may require more than that. So I put a 5 there as a minimum. So it should be in a good interval. So that should be good enough to cover all the range. So I typically do 6 or 7. 5 is okay. What's the difference between the double injection? It's a plus minus 15% in my lab. But it always depends on the concentration. If concentration is really, really low, below LLMV, it doesn't matter. If it is close to LLMV, the number will not change. For example, if you have something 0.012 versus 0.014, this is bigger than 15%, and this is acceptable because you need to talk to study director to accept this. I don't think this is the issue because when you do the rounding, it's all gone. And also when you put in the OECD calculation for MRL, there's some OECD MRL calculation, the number will be exactly the same. So basically, this is the same. Even you change this to 5 or 6 or something, the number will be the same. So it will not affect your result. It will not affect the whole study. And also depends on the residue. Okay, if your residue level is to about 1 ppm, you have QC or anything or other sample less than this, it doesn't really matter. So you do need to talk to the study director because your double injection is greater than 15%. You do need to get approval, but it shouldn't be any issue. So there's multiple things there going on. So in this case, so I put a 15% as the number. You need a number there. The next criterion is the date, the holding time. So your extract, this is mandatory. This is not science. So the extract between extraction and analysis, we put it 14 days there. We don't want it wait too long because things will change. Okay, and okay, the residue levels. Okay, so if we have the residue levels 1 ppm, you need to spike the same level. Make sure this is in your range because nowadays we use more and more like SPE or liquid extraction. It may saturate the SPE cartridge. That means the highest number you get. If you don't spike this higher level, make sure this is good. Sometimes you will get wrong number. Maybe this is 5 ppm and your number is always 1. So you need to have something. If your residue is 1 ppm, you need to spike something at least double than that. Normally it's double. So make sure you spike 2 ppm there and you get a good recovery. So that means your residue number is good. Okay, I do see some questions there. I still want to case double injection is 15%. What result will support both injection? If it is 15%, you take somewhere average for that. So the difference there, and this should be okay because once you have the average right in the middle, your numbers should not be too much away from everywhere because your matrix interference will be bigger. The interference will be bigger than your error here in the analysis. So, okay, and the last one is if your control is contaminated. For example, if you control your LLMV, in this case, is 0.01, and your control is contaminated, and you will never be able to ppm. You will never be able to get MMV percent M. No, not M. LLMV. You will never get to let's say method validation or spike. Let's say we call that MV. MV level at LLMV. So in this case, there's no way you can get to 70% and 100% range. So what's the requirement for this? So the residue should be less than, in control, should be less than LOD. If it is greater than LOD, you will never be able to get your spike in this range, which you put it here. Okay, when you spike low level. So sometimes the field, or for some reason, it's already sprayed this pesticides in that piece of field, then you always stay there. And we do know that because when we do calculation, when we do LOD calculation, so LLMV is equivalent to LOQ. Is that right? So LOD is, let's say LOQ is 10 times, no, it's 3 times, typically 3 times LOD. It depends what you say. Okay, so LLMV is equivalent to LOQ. So basically, this is, if this is equal to LOD, so your recovery at LLMV will be, if you get 100%, you will get easily to 133% recovery, which is not acceptable. So anything you find any contaminated control, you need to talk to study director. Something's wrong. So you had a third of the residue higher than it's supposed to be. So that's a little bit complicated thing. So normally this should be less than a third, less than LOD. Okay, so those are the requirements. Okay, let's just go quickly because we still have the QA form need to go through. Well, storage stability, that part is simple. When we have the sample, we spike it immediately. Even you don't analyze the sample, you still have to spike. So this is the requirement. Okay. And same thing, if something wrong, contact study director, talk to the study director. So the SS, we call that S and S. So SS is the same requirement as MV. MV is at the very beginning you spike, you extract it right away. SS is you spike the sample, you leave there in the freezer for how many months? Okay, before you analyze. So this could go down dramatically. It depends on the freezer, depends on the chemical, depends on the crop. So if as the same criteria, if the recovery for SS, the SS is at the middle, typically is at the middle level of method validation. So you have 0.01, 0.1, and 1. That should be in the middle one. That should be in the middle one. Okay. So the recovery is the same, should be 70% and 120%. And we do know any pesticides in the storage, the concentration, for example, this is the concentration, this is the time, it's always go down this curve. So it's always go down this curve. So it now depends on how this curve is and where you are. Let's say we draw a different line. Let's draw a different line here. The curve should be always around this. This is the nature of degradation of any chemical. So if we put requirement there, for example, this is 100, and this is 70 up here. So now, if your storage, this is your storage. If your storage is between here and here, you are good. If it is above that, it's not good. That means your study is something you need to change your study. Your study is wrong. Okay? So the study director should give you a very good sense how you handle that. And for example, most likely the companies did a lot of work. They make sure your storage time here, they will give you the time. The sample must be analyzed by how many times, how many months. So typically this point is no shorter than 24 months. That's typical. but depends on the chemical. Like I just mentioned, the one chemical that's only by how many days? Maybe less than 7 days. Okay, I do have a question there. Okay, the question is, we report the mean of both injections. Yes, you in the calculation. Maybe we can go through the calculation a little bit. In the calculation, you put the both of them individually, but when you do the report, tomorrow we'll talk about report. We will report only the averaged number, or the number you know it's correct. For example, if you made a mistake on something, you can tell. Okay, yes. The correct answer is yes, you use the average number. You report both. You do use the average number. Okay, now there's a lot of other thing there. This is you have to do to calculate R squared value and meet your criteria, which we just mentioned. So that's fine. So the storage, we got exactly the same idea there, and we need to talk about this should be always in triplicate down here. Okay, the same idea. Okay, you cannot just analyze one or two. Okay, and recoveries here, it could be high or could be low because of the same reason, because you have sample, you have matrix, and also after such a long time, maybe a little bit water evaporation or something, or maybe some kind of interference, or maybe your preparation of standards, because this is after 100 days or after a half a year. Your preparation of standards may be slightly different. Maybe chemist A ran the analysis and chemist B spiked the storage sample half a year ago. So they use different way to do. So this difference is acceptable as long as it's in the range, which is the same range we have, 70% and the 120%. So if it is out of this range, that's typically SS is in the lower end here somewhere, about 80%, 70%, which is normal. If it is really lower than 70%, your work very likely will be rejected. And we don't back calculate. Some people can say, oh, this is my storage. My sample is the same condition. Can we do the back calculation? In science, you can, but reality is people don't trust how you do the work. Most likely people will reject your work. So this is important. Make sure you analyze the sample as soon as possible. Don't wait 5 years to analyze, because your recovery SS recovery will be low. This is my form. You see that's exactly the same format as I mentioned. And you will see this is the calibration curve here. This is the same thing. And R squared value is 9978. Okay. And we do the storage sample 3 here. Now, this storage sample is a lab sample. It's not a weathered sample. You do not have to do double injection. You do it, great. You do not have to. And recovery is here. This is concurrent. This is spike immediately. This is your storage. So which is very similar. So you do the calculation like that. And when you we can do the report, we can do that. If it is multiple, you need to average them. For example, if you do multiple injection, you need to average them to report. You have two results, and within 15%. And at the same thing, we have the first set of calibration, but it's exactly the same idea. And the second run calibration. Then the sample in between. So that's exactly the same requirement we have. And how we do LOQ, LOD, I just skipped that because we have the way to do that. If you went through my training, you pretty much know how to do that. I just quickly show you the form we do calculation. And that's why I mentioned last time, I prefer something 7 or higher, because this number is easy to remember, because this is like a pi, 3.14. And the minimum is 6 in the IL4 studies, because you use those 6 to do statistical result calculation. Okay, we just skip that because we don't have time. Yeah, we don't have time to go through that. I want to go through the questions. Let me see. Maybe do this. Maybe we do the QA form, which I can. We do the QA form tomorrow. So today we can have a little bit time to go through this. Otherwise, we'll be a little bit late. Let's just do that. Okay. Let's calculate this first. We do the QA form tomorrow because I was thinking. Let me show you my. What's that? My QA form. Okay. This is today's agenda. We're supposed to finish all these, which you already did. We're supposed to go here. Okay, we're supposed to do the QA form, which I already have it here. Okay, so let's do this tomorrow because we want to probably we want to just go through this. We spend too much time talking about the criteria and some other thing, but let's do this. Maybe this more you have more interest in doing calculation. This is one way to do the LOD, LOQ calculation. Okay, if you say you have different way, as long as you have science background, you have valid resource to do the work, that's fine. Okay, this is based on this reference which we put down here. This is our references down here. So you can find this book to the calculation. So this is a handbook of environmental analysis. So you can use your own, but this is accepted by EPA, accepted almost everywhere. So what we do is, some people may argue your LOQ should be your instrument analysis, not calculated. Because you spike something, your instrument can read, then that's good. But this is calculated based on statistical results. So this is different. So it depends on how you say, because by definition, LOQ is you can read it back. But we calculate, but the close enough. Okay, we know the spike level. The spike level is here, where the spike level, which is LLMV level. Okay, this is LLMV, which we spiked in. That's by definition. So this is 0.005, and all the recoveries are here. Okay, so based on this, we do a quick one. We do the student t-test, and then you will have the name there. Of course, if you have one number, there's no way you can do any statistical results. If anything smaller than 3, the number is totally non-reliable. So basically, when you do the statistical results, you have to go above 3. Otherwise, the number is not good. So in this study, the DIQUAD, this study on onion, we did 7 level. So first, the 3 is we see the dates. You can see that this is the method validation. It's in triplicates. Okay, now you see the numbers there. Now we ran all of the samples with the QC at those level. So we got them. And you will see the number is from 84 through 104, something around there. So we did 7. Then we use the student T number here, which we put the T number down here. Okay, so what we do, the calculation is very, very simple now. Okay, we remove all these. Remove all these, remove all these. We don't need any of these now. Okay. Okay, so what's the number we need to use now? We use this standard deviation. We can calculate all the number we get from there. We know the spike level is this. And the average one, of course, if you average everything, is this number. but this is the standard deviation for all these numbers. So that's how the method is fluctuating. So this number times the student T, it should give you the LOD. And it depends on your definition. That's why I say this is statistically calculated. This is not the real. It's based on number calculated. So normally we just simply times this 3, you will get this number. That means this LOQ, by our definition, by our calculation, is 3 times LOD. Okay, so if you do that, you get this number. And this is the calculated LOQ. Okay, now we need to remove all these now. We don't need any of these. Okay, so let's compare our calculated number versus our spike number. Okay, we spiked here. Oops, wrong one. Put it there. So we spiked this level. And this is what we calculated based on our analysis. So the number is very close, actually. So we report this is calculated. You see, this LOQ calculation. This is not the real number we analyze. It's based on the analyzed number we calculated, LOQ. So we report that. Okay, so that's how we do it. Okay, so the next we just keep going through that because it's just like parent metabolites. We still have probably 5-10 minutes. We can go through the questions we had before. Okay, we did the first one. We know this is true or false at the very beginning. I was given to you to figure that out, what we learned yesterday. But let's just go through the answers, what we have. I'm sure you got old ideas. Let's just get to exactly what we want to say. A copy of this or pages. Okay, if you make a copy from a photocopier, so that is called exact copy. Is it true or false? Okay, I'm reading the chat box. Nobody said true or false. We just went through that. So this is false, I just mentioned. Okay, because when we talk about that exact copy, we need someone to verify. Oh, yeah, somebody put it there. I'm sorry. Maybe it's a little bit lag. That's fine. Okay. So we need somebody verify. We need a signature, somebody to sign on that. And we need a date. Okay, let's read the second one. It's a computer printout. We have everything. We have the instrument. We have our Excel file. So computer printout. Okay, doesn't matter from where. Okay, so it's a raw data. It's true or false. I saw somebody saying true, somebody saying false. Okay, let's say you did some Excel calculation. Is that Excel calculation printout? Is that true? Is the raw data? Okay, I see a lot of true or false, true. Okay, that's exactly the same idea. Okay, if this copy, you sign and date, it's true. The same thing for any printout, you still have to sign and date. If you don't sign, don't date, it's not. So that's why when you do your work, when you finish that, sign and date immediately. So that's original raw data. Otherwise, it's not. Okay. So the data must be verified by the user. Otherwise, it's not. Okay. The next question. Okay. If you do the GOP work and your facility is doing other work, okay? So the GLP work may be done in other labs, which is running different type of work. That could be GMP, GCP, or ISO, or none of these. Is it okay to run GLP in that lab? I saw some questions saying true. This is true. If this is false, that means you must be certified to do the GLP work. Okay? The correct answer should be this is true. You may do it, but you have to follow all the requirements. You do not have to certify your lab, or the lab must be only doing GLP. So the thing is, yes, you do need to, especially EPA GLP, you can do your GLP work, but you have to follow that. Yeah, it doesn't matter you have these or not. Okay, as long as you follow, you may do your work. So that's why we have a GLP state compliance statement to say. The next question is, can anyone go to your lab to take something away, like a photocopy? Some companies, they will say, yeah, this is confidential material, but this is a special person. This is the EPA inspector. Normally, EPA inspector go into lab, go into some places, they don't take anything away. Even they ask something, they will ask permission. For example, they come to the lab or a field to do inspection. I want to see your CV. I want to see your SOP. They can ask, but they don't take these away unless they get the approval from the lab, because this could be the property of the lab. So the thing is, the keyword is can, not normally do. Yes, if they find something wrong and something suspicious or objections or some practice or something, they can. But in the normal case, they should ask permission. So the answer is yes, they can. Okay. The raw data must be co-signed by a second person. So basically, when you work in the lab, so one reason is one person can do all the work. If there's no other people to verify, that could be a lot of suspicious activities going on. The data could be bumping up and down, and something could be shady. So is that true per GLP? Okay, maybe the computer is a little bit lag. Is it true or false? Well, you know that. It depends on the size, depends on that. Sometimes you may not have the second person there. So it does not have to, as long as there's one people. So it should be false. You do not have to. Okay, I saw the answer here. Thailand guess to say false. Okay, Chong and hey, and well, correct. Okay, the next one, the raw data must be directly entered into the bound book. Okay, everything, if this is a loose page, acceptable or not. Or everything must be bound in the book. Okay, of course, we know that. Nowadays, the older days when we do the work, it's always there. And that was the requirement a long time ago. But they changed the requirement. No, it's not necessary. Okay, because right now it's all loose pages, as long as you can link them very well, such as sign-in date, the page numbers, and you have the index to tell. So no, you do not have to. Okay, the next question. QA must keep a copy of the lab SOP. We know that when we do our work, we have our SOP, and QA does the inspection. And a lot of times we send a copy to QA. Older days, we need a QA to sign approve, and that's a wrong practice. QA cannot approve the lab SOP, cannot prove anything or verify anything. The only thing QA can sign is acknowledgement. I received it. That's the only thing. QA not supposed to say anything about the SOP. Okay. But the different thing is, does the QA have to keep a copy of the lab SOP? So it's true or false. Okay. Well, we know that QA has to keep its own SOP. How about the lab SOP? It's not QA's responsibility to keep lab or field SOP. Forget it. You give to me, I read it, I do the inspection, I can throw it away. I don't have any responsibility to keep anything. So no, QA does not have to. He keeps it, that's good. He does not have to. Okay. For SOP change or anything, newer version, study director needs to sign, needs to authorize. Is it true or false? Well, what is the requirement for SOP, for working method, for protocol? So who signs on the protocol? Let's look at the signature. So if it is a protocol or work plan, let's say protocol, there are two signatures there. One is called sponsor. He must sign first, followed by study director. That means the GOP starts. Okay, so that's the protocol. How about SOP? SOP is related to the facility. So in this case, it needs the boss, which is the testing facility manager or management to sign. So in this case, there's nothing to do with SD. It's the management. It's the boss. It's SD's boss. Unless this boss gives this person, any person, he can say, okay, I ask you to sign. Then that's fine. So basically, study director does not have any authority to sign an SOP unless the big boss assigns a person, because this boss, I'm busy, I don't have time. I give you the right to sign. Then that's fine, as long as this person is not QA. So the answer is wrong. The study director does not have the authority to sign any change on the SOP. He can change the protocol, which is above SOP, but he cannot change the lab practice. Okay. The next question, what's the GOP requirement in terms of the labeling? Well, we learned that yesterday, so right? We talked about multiple times. Okay. So expiration date must be on there. Is that right or wrong? Identity, what is there? The user initial date, the safety information, the storage condition. So select all correct answers. So that means it's more than one correct. I will tell you, in my lab, I keep everything. But this is not GOP requirement to keep everything. My lab, we have everything. We have dates, we have identity, even we have solvent if it is like if you use acetonitrile or if you use some other thing. Okay, so we have username, date, that you see that. We have safety. We have to put a box there. We check the box. This is a flammable or this is something, and we have the storage condition. So in my lab, I use everything, but that's not a GOP requirement for everything. So let's read what's GOP required. GOP does require everything needs to be signed by the expiration date. It must be there. Okay. I've got a lot of answers there. A, B, C, E, A, B, C, E, A, B, D, E, A, B, C, A, B, C. Well, let's go through them. Let's see. Well, you have your own opinion. That's why I put everything on my label in my lab. It's not necessary GOP requirement. Identity must be there. So what is in there? A, B for sure is correct. User initial date? No, it's not necessary. So if it is a solvent or something, no, it's not necessary. So if you prepare something, it's better to keep it there. Okay, so it's not necessary. It's better to have it there, but not necessary, not a GOP requirement. Safety information, no. GOP is more talk about documentation, talk about the integrity. So it depends on your lab, your company. They may have different requirements. Let's say we are located at Michigan State University. University asks you need to put it there. Otherwise, you are not complying in compliance with the university safety rules. So yes, we put it there. By university rules, we put it there. So it's not a GOP requirement yet. You cannot say GOP does not care about safety, but it's not required to be in a small label there. Okay, storage, yes, GOP requires the storage. How do I know your sample, your material is still good in there? So the correct answer should be A, B, and E. Okay, let's do the next one. So who can be the role for study director? Let's say in the study. So can study director be the archivist? Okay, again, this is a rule, or that means it's multiple correct answers there. So, well, we know the QA is not right. He cannot be the QA because QA is here. QA must be under the big boss, which is a facility manager. Sometimes we call that testing facility management. That's the boss. The QA must be direct. Then all the research or all people or other people must be here, including study director, including field lab, including everyone, all other. So it's totally separated. So we know QA, study director cannot be QA. So, and it depends. So any lab, if it is too small, the two positions must be there. One is study director or equivalent. One is archivist. They can combine. Yes, you can combine these two, but you need two positions. One people can take two positions, no problem. So archivist, yes, he can, but normally you assign one archivist. How about the field people? How about lab people? Yes, if this lab is too small, it's only one people doing the lab or doing the field, the study director can do that. As long as study director is here, is separated from QA, that's fine. Okay, can the study director be the CEO, which is the big boss, which is this guy? Of course not. Otherwise, we don't need a QA. No. We do know that we cannot be the QA. I think that's long enough for today. Any questions? Put in the chat box where I can answer that. Yeah, thanks for attending. Yeah, I know Michael always say all the thanks to everyone, so I probably need to repeat that if I miss something there. Sorry about that. Yeah, thanks for Perry for this training and for USDA for the funding, and also thanks for the technical person behind the scene. I don't know all your names. I do know the lady sent an email to me, Nazia. And other people, sorry, I don't know your name. Thank you for your support. And I do want to thank all of you attending this training. Looks like it's more than 50 people. I'm so happy to see that. Okay, send me an email. You have a question. So if there's no question, we can put a pause today, and we can resume tomorrow. I know it's quite late there. Now you can see outside my window. It's very, very, very bright outside. You can see that. Okay, so that's good. It's 9 o'clock here. I know it's in Asia. It's 9 o'clock or 8 o'clock or a little bit later or earlier, later that time. But anyways, thank you for your time, and we will resume this tomorrow. Thank you very much.